Good day, everyone. Welcome back to our science subject. Today, we will be learning about light energy, colors, and images. Here are the objectives of this lesson: to explain the different colors of the spectrum and to determine the images formation by mirrors. You know that light has different colors. Sunlight and lights from electric light bulbs appear mostly colorless or white light. When a white light beam passes through a prism, the light is spread and forms a band colors in a certain order. This band of colors is called spectrum. The colors in the spectrum are red, orange, yellow, green, blue, indigo or azure, and violet. This shows that white light consists of these 7 colors. The splitting of white light into a spectrum is called dispersion. Now, let me just play this video for your further learning about dispersion of light.
Dispersion of light. In this module, you will learn about the dispersion of light. Sometimes after the rain, we see a rainbow in the sky. It looks spectacular, doesn't it? Do you know how a rainbow is formed? A rainbow is formed due to the phenomenon of dispersion of light. To understand what dispersion of light is, let us perform an activity. For the activity, you need a prism, a white sheet, and a cardboard with a small hole at its center. Place the cardboard at a position such that the sunlight falls directly on it. Next, keep the prism such that the light passing through the hole of the cardboard falls on the surface of the prism. At the other end of the prism, fix the white sheet as shown. As the sunlight passes through the prism, you will observe a beautiful band of colors appearing on the white sheet. If you look at these colors of the band from the bottom, they are in the order violet, indigo, blue, green, yellow, orange, and red. This sequence of colors can be remembered by the acronym VIBGYO. The light coming from the sunlight was white light. Are you wondering from where this beautiful band of colors appeared? Actually, the white light consists of 7 colors, namely violet, indigo, blue, green, yellow, orange, and red, which we saw as the band of colors. When the white light coming from the sunlight falls on the prism, it splits this incident white light into its constituent colors. The splitting occurs because different colors of the sunlight bend through different angles with respect to the incident ray when they pass through the prism. The red light bends the least, while the violet bends the most. Thus, the rays of each color emerge along different paths and become distinctly visible. Thus, we are able to see the beautiful band of colors. This phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion of light. The band of constituent colors is known as spectrum. This phenomenon was first discovered by Sir Isaac Newton. Now that we have understood what dispersion of light is, let's understand how it causes the formation of a rainbow. A rainbow is generally formed when the sun appears just after it has rained. At this time, many water droplets are present in the air. When the sunlight passes through water droplets in the atmosphere, each water droplet acts like a small prism and refracts the incident sunlight. As soon as the sunlight enters into the prism, that is, the drop, it splits into its constituent 7 colors, vibgyor, within the drop. When this band strikes the other edge of the drop, it gets reflected internally towards the first edge of the drop. As the band reaches the first edge, it gets refracted again and finally comes out of the raindrop. This band of colors which finally comes out of the raindrop is what we see as rainbow. A rainbow is always formed in the direction opposite to that of the sun. Thus, the appearance of rainbow in the sky is due to the dispersion of sunlight by the water droplets present in the atmosphere. Dispersion of light not only results in the formation of a rainbow, but we can see this effect in our day-to-day life as well. For example, the beautiful band of colors we observe in water fountains, soap bubbles, and CDs are all due to dispersion of light. Let's recap. The white light consists of 7 colors, namely violet, indigo, blue, green, yellow, orange, and red, vibgyor. The phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion of light, and the band of constituent colors is known as spectrum. Formation of a rainbow and beautiful band of colors observed in water fountains, soap bubbles, CDs, etc. are all due to dispersion of light.
All right. So you just have watched about the video of dispersion of light. There's some question here, but why does a prism split white light into its spectrum? Above you have learned, or from the video, you have learned about the effect of refraction already. Refraction happens when light passes through the surface of a denser medium because the speed of light is lower in the denser medium. However, the speed of light slightly depends on its color, and because of this, the angle with which the light is bent at the surface also depends on the color. So the direction in which the light travels after it's refracted is slightly different for each color. This spectrum that is generated by a prism is the same as the one that you can see in a rainbow. How rainbow occurs? Rainbow occurs because of the dispersion of the sunlight in the water of the raindrops, like what you have seen in the video earlier. And now this is the example of the rainbow. All right. The leaves of all plants are green because leaves reflect green light and absorb colors of white light. If we shine red light on a plant, that light is absorbed by the leaves and no light is reflected. This makes the leaves to look black. If we shine green light on the plant, the light is reflected and we can see the green leaves. All right. Why do different objects have different colors? The reason is that colored object absorbs certain colors and reflects others. Only the reflected light can hit our eyes so that we can see it. Here are the 3 factors. 1, the color of the light that shines on the object. 2, the color of the light that an object absorbs. And 3, the color of the light that an object reflects. All right, as you can see in this picture, the white light coming into the leaf or to the leaf then it reflected to our eyes as green light. All right, because the surface of the leaf is green. Also, the sunlight, all right, coming into the leaf absorbed the light colors coming from the sunlight and reflected in our eyes as green color. All right. What happens to the light that is absorbed by the leaves? Leaves absorb energy from the light for the process of photosynthesis, and the carbon dioxide and water turn into glucose and oxygen. Note, this process is important because it provides food to all living things like us. All right. There is a production of vitamin D. The energy of the sunlight is also used by our skin for the production of vitamin D. It is a necessary for the supply of our body with calcium and phosphorus. But if we expose to direct sunlight for a long time, it can lead to skin cancer. Using sunblock lotion is necessary as our protection. The advisable SPF number is 50 for the protection of our skin. In the picture, it shows the sunlight and the skin. The vitamin D is already in our body. We need sunlight for the activation of this vitamin D. Reflection of light by different surfaces. In this picture, you can see the three surfaces. We have the white surface, black surface, and the red surface. And then also on the other side is the plant with leaves. We knew already that the sunlight gives the white light, all right, and absorbed by the leaves. And then when we look on it, it gives us the green color reflection. All other non-living objects convert the energy of the light they absorb into heat. This is the reason why dark objects are a bit warmer. As you can see here, the black surface is the dark object in the example. So it gives us a bit warmer heat than light objects. All right. When light shine on them, dark objects absorb most of the light. The black surface absorb most of the light, all right, that shine on them and convert into heat. As you can see in the picture, no light reflection or no light reflected because the black surface already absorb most of the white light. While the light objects reflect most of the light, in the white surface, the white light, and then reflected most of the light they absorb and convert only a little bit of the light energy to heat. All right. We can also use the energy that is contained in the sunlight in our daily lives. The example is the solar panel. All right. As you can see in the picture, solar panels are designed as a dark surface so that it can absorb all the heat, absorb all the light and convert into heat that gives power into every houses. All right. That is the part 1 of our lesson. Thank you so much